All right. So when it comes to geometry, we have parallel lines for starters. If we're looking at parallel lines, what we have is the following. We've got parallel lines, which is quite a few parts to it. All right. So I'm going to draw a line through here, and this is going to be point A. Well, let's just call this angle small a, B, C, D, E, F, G, and let's say H. And these two lines are parallel. All right. So the first thing I'm going to look at is the concept of an alternate angles. All right. So let's look for alternate angles. Alternate angles. Let's color code it. Let's color code it, and let's say alternate angles. I want to make them the color green. All right. So alternate angles are, by the way, equal. The concept of the alternate angle is also the Z shape, where those two angles are equal, but sometimes it looks like that, and those two angles will be equal, where you have two parallel sides, and it's almost like you're traveling on a road, you get to a roadblock, then you change direction, and you take an alternate route. Right? Those angles on the inside form alternate angles, which are equal. If I look at this, if I'm traveling on this route, and I change direction, and I carry on this route, these two angles become alternate. So those two angles are examples of alternate. It'll never be on the outside. Alternate angles are always on the inside, and they're never in the same U shape. They're always across a line. You'll have this across that line, you'll find the other angle there. That's angle D and angle E. And at the same time, A is equal to F. Right, so A is equal to F. All right. So alternate angles over here would mean if I'm traveling this way, alternate route, I go this way as well. You can see this is an obtuse angle, and this over here is an acute angle, and that's alternate angles. Let's look at the next one now. Next one in orange is going to be co-interior angles. Co-interior angles is built on the idea of a U shape. So you have some kind of U over there, which can be in any direction. It can be facing upwards, downwards, left, or right. But co-interior angles are not equal. They add to 180 degrees. So that would be A and E. So angle A plus angle E equals 180 degrees. Another word for 180 degrees is also known as supplementary. So they are supplementary. 90 degrees is complementary. And if we look at this side, those two angles over there add up to, say I keep this as a double line because they're equal. But we can see that those are going to be co-interior. So D plus F equals 180 degrees co-interior angles. Co means together, interior means on the inside, and you can see these two angles are together on the inside. All right, those two as well. Okay, the next one is corresponding angles. Corresponding angles are in the same, you could say, quadrant or corner. So, for example, B and E are corresponding angles. Corresponding angles are spotted by using the F shape. Corresponding angles spotted using the F shape. So the F shape can be in this direction, it can be going downwards, it can be going left, it can even be going upwards. What you'll spot is those two angles which are equal. They don't add to 180, they equal. Divide every intersecting line into that many parts, and you can see that if you draw this like this, you can see that this is corresponding to that. They correspond. Or this bottom part corresponds to that bottom part. So they're equal. Okay. So likewise, B will equal E for this, corresponding, and C will equal F, as well as D will equal B, but D will also equal H. Let's put it as a cross for now. So D equals H. And let's make this one triangle. A equals G, corresponding angles. All right. Corresponding cointerior, and those are your parallel line angles, the main ones. That's actually it's all of it. So we got only one of them which add up to 180. The other two are equal. Alternate angles are equal. I'll just make a note of that. And the other two, the other one adds up to 180. So equal adds to 180 and equal. Corresponding angles are equal. Okay. So let's suppose we're going to a quick example of a question. We be given a triangle that looks like this, and we are told the following information. So that this is 35 degrees, x 45 degrees, y z. All right, and let's say t. Now I want to try and use the formulas. I'm trying to use the reasons, not formulas, the reasons, alternate, co-interior, and corresponding for this example. And I want to find x, y, t, and z. All right, so we're going to find x, y, t, and z. The first thing I can see is that x and 35 both lie in that corner. So they're corresponding, and therefore they're equal. We write down the statement, x equals 35, and we write down the reason, corresponding angles. We can also remember that these two have to be parallel lines. So let's just state that they are parallel lines. And we normally state that in the reason. So if you ask for a reason, maybe make sure that you write down parallel lines every single time you have any of these. It's because of the parallel lines that the alternate angles, the co-interior angles, and the corresponding angles actually exist. Without the parallel lines, it does not. So if you have a line going this way and a line going that way, then those two are not going to be co-interior. Those two are not going to be corresponding. That would be false. But in this case, because of the parallel lines, that's why we have them existing. Okay? All right. So x equals 35, corresponding angles. Let's try and see if we can find a co-interior angle. Co-interior angle, I can see t plus 35 equals 180. And that's co-interior angles as the reason. Again, we just write parallel lines, part of the reason, why. And then t becomes 145 degrees when we minus it from 35. When 180 minus 35, we get 145 degrees. So this angle here is going to be 145 degrees. Let's put that in there. X equals 35 degrees. Whenever you're doing a question, make sure that if you get some angle, write it in the diagram, because then you can visually start seeing a bigger picture, which gives you the other values. Now, there are many reasons to get anyway. We could have used angle on a straight line as up to 180 degrees as well to get that. But we want to specifically zone in on corresponding co-interior. So let's look for one more. Let's look for alternate angles in some kind of Z shape. I can see that y is equal to z because of alternate angles. But I need to find y first. So I'll find y by stating that y plus 45 equals 180 angles on a straight line adds up to 180. So y equals to 135 degrees. And then therefore z will equal y, which will equal 135 degrees. And the reason is alternate angles, parallel lines. Okay. All right, so that's just a simple example explaining that from there.